I'm Bree from the Soil and Water Conservation District in Hendricks County, and in this session we're going to be talking about soils. So I've got a little demonstration here to explain some of the different soil principles that we work with in our office. So I have two different soils that are going to be in this experiment today. So one soil has been farmed with what we call soil health practices. So these practices are there to protect the soil and prevent erosion, and also to help feed the microbes and the living organisms that live in the soil. Whereas the other soil has been conventionally farmed, which means that it has been tilled. So if you've seen big farm equipment that run through the soil and churn it up, that's tilling. So this has been tilled, and it hasn't had other soil health practices like cover crops, which are crops that grow after corn and soybeans. Those haven't been applied. So this dirt is pretty much just left bare most of the year unless it has corn or soybeans. Whereas this soil, when it's been farmed with soil health practices, has living roots in it all year round with cover crops and is left undisturbed. So the reason that we do soil health practices is to help to infiltrate water into our soil. So when it rains, that water has to go somewhere, and we know our plants and animals need water. So when it rains, we want our soil to act like a sponge and soak all that water in so that our plants have it, and also to help alleviate any flooding that we might have or erosion. And erosion is when soil particles are picked up and washed away with water. But if we use our soil health principles, that water can soak in our soil and be held within there instead of running off. Whereas the soil without conservation practices or soil health practices, it almost looks like a little block of concrete. It doesn't have any spaces or holes for that water to soak into, so it's not going to act like a sponge. So in this demonstration, both of these are going to be submerged in water, and it's going to kind of mimic what would happen to the soil if we got a big rain event. So the healthy soil is going to be on your right, and the soil that hasn't been used in conservation practices or soil health practices is on the left. So we'll let these soak for just a minute in the water, but you can already kind of see what's happening. So if you notice, the soil on the left is breaking apart, and you can see the soil particles falling to the bottom. So soil by itself, without organisms or any other living animals or organisms within it, like worms, is very fragile. And when there's life in our soil and it's being protected, like this soil on the right, there's actually a lot of little holes and pore spaces where those worms have lived, and that enables that soil to act like a sponge and soak the water in. The other thing that living organisms and plants do to our soil is help it stick together. So our soil sticks together with those glues that either come from the plant roots or that come from the organisms that live in those. So the soil on the left that is falling apart has not had as many living organisms in it, and it has also not had as many roots in it to help keep that soil stabilized. So if we were to have a large rain event where the soil is completely saturated with water, our soil, if it's not properly taken care of, can break down like this one and is going to erode away. So those soil particles are going to be picked up by water and washed away. And when that happens and we get sedimentation, or we get soil particles in our streams, it causes cloudy water, like you can see in here. And I'm sure you can imagine that fish and other animals really don't like living in that muddy water. They want clear water to live in and to drink just like we do. The other thing to remember when we talk about erosion in sedimentation in water is that a lot of the fertilizers or things that are used in farming or even just for our backyards, those are designed to attach to soil particles. And most of those things cost money, but also can be damaging to our environment. So we want them to stay attached to those soil particles. But if our soil particles are eroded away and in the water column, like you can see here, we can't keep those at our house. So we're either losing money by losing our fertilizer, or we're also being a detriment to the environment by not keeping those things in our soil. So you can see it is falling apart very quickly, whereas the one on the right, so if we have any fertilizers or any chemicals that have been put on this soil, it is all staying in place and it's holding that water like a sponge. And the other thing to think about too is our soil is what holds our plants in place, and it also has the water that's available for our plants to take up. So when it gets dry during the year, if we're not getting much rain, we need that soil to be a sponge and hold the water. So when our soils act like the soil on the right, they have a lot of water holding capacity to be able to give our plants water all year long. Whereas this one, it can't hold any water, it just breaks apart. So that is a demonstration on two soils that had different types of management on them. And in the resources page of this website, there's also a soil activity.